Alright guys, so every time I think I'm done, I think of something else I need to share with you guys on the engineering side of things, or on this side of things, which is the building side of things. So now I have taken this now because I didn't know exactly what I was going to build. When I first built the wing, I was just building a monoplane, and it works. If I only wanted to do 2 or 3 channel, this is a great design, but it's narrow here and doesn't have a lot of strength on its own without a lot of bracing and other things going on because it's a fairly thin wing here. I recommend if you're going to build a Wano wing, copy exactly this wing and you will love it. Copy vaguely the shape of it and the size of it and you will love it. It's a great monoplane and it will take the weight. You can copy the tail as well. But here is the thing. When I looked at what I wanted, I realized a few things. One, I wasn't going to have room to mount all the servos I want if I wanted 4 channel. It makes it really awkward. Two, it means I know I need to go with a double receiver board and servo board. So it has 2 servos and then it has the receiver built in. If I did that setup, I'm looking at about $50 for that one piece. And to be honest, guys, it pushes the price of the build to a point where I don't want to do it. It would take 3 months at least for me to just get the money together to get the electronics. And that is a lot, guys. I to be honest, it's beyond my means, and I really don't know what to do about it. I am going to talk to some folks. I was pretty heavy into the hobby for many years, and I really want to show them that I'm coming back in a big way, and I'm going to do it with designs, guy, with creativity, and that is going to be my path. But if I do this right, you guys are going to have an amazing biplane, guys. And I did. I gotta say, I did. It flies so nice. When it hand tossed, it climbs really nicely. And it actually needs more weight. All of the behavior it exhibits says, give me more weight, which is what I designed it for. And the reason is the monoplane by itself didn't do that. When I put the weight of the battery and the motor and all that, it flew perfectly. It climbed a little bit, which is good because it was going to need a little more weight in terms of a pair of servos at least, and another servo and a little receiver and a little ESC. So the way I had planned originally to do that was to lay the ESC here, the battery underneath, 2 servos on top of the wing to do the ailerons, 1 servo in the middle at the back of the wing, or maybe even just here at on the board. It's on the rod itself to run these 2. And that would have worked because I only wanted to run 1 if I was going to do that monoplane. That is a great beginner version, but I recommend you do it with the bigger wing. You'll have more lift, it can handle the weight, and it'll be really, really sweet, guys. This is a really dialed in design. I have tested it with a fair bit of weight, and I kind of want to show you from every angle, because everywhere you look on this, there are lift surfaces. There's VGs, as I showed. The top one is unchanged from the videos where I've shown it how to build it. And this is only just bent here. It's not even done perfectly, guys. But when you watch it fly, you wouldn't know it. There's a little offset here, where one of these is slightly higher and the angle here isn't perfect. I have to adjust it. But that brings me to my point for this video. When you design something, no matter how good the design, in this case, I've proven a lot of things. 1 is that it flies incredibly well. 2 is that it handles weight incredibly well. 3 is that it slow flies incredibly well. 4, it is able to handle mistakes you will make in the building, and they are easily accounted for in the design of this build. It is so locked in, guys. I have a few more things to show you. Take a good look at this. And then look at the landing gear bracing really closely. And you'll notice it's triple layered and quite strong as a result. And when you look at these angles, you start to understand why it's so locked in. The little upturned wingtips on top with downturned wingtips. Upturned on the bottom, downturned on top, means this will fly, theoretically, even upside down. When you give it the right angle, it will very well fly inverted. It'll also roll. Now, one of the reasons it can do that is because of the cutouts in the wing. But these angles are important for you to get right. So, and the ailerons, it's important that they line up because you're going to connect those later. There are lots of things that are important that you can't screw up. But if one landing gear is a little heavier than the other, believe it or not, this thing won't care. Little weight imbalances, it does have a little weight imbalance to the left, and it doesn't make any difference. It didn't matter at all. I've seen little tiny imperfections in it since I built it, but I didn't build it measuring. I build it by eye. I design the wing. I lay out the measurements I want in my head. I sketch a rough shape, then I cut it out, refining that shape while I cut it. It's usually almost every single time is a slightly different shape that I end up with than I started out with, because I keep modifying and adjusting and doing little things to make it the way that I want. Now, there's also a little tiny imperfection here where this needs a tiny little trim to make it smoother and more rounded, like here. But that's about it. Also, I'm going to trim these little tiny tips if I decide to, but I want to try this first because it's been flying really nicely. I'm not going to mess with it. But all these little imperfections have to be noted, and I have to make preparations to correct them. So this is what I call blueprinting. So now I have a design that works. Now I need to look at it in detail, make sure that the heights here are perfect, the inner heights are perfect, lay all that out. And the best way to do it is to take the one that matches perfectly best what I want, lay it all out mathematically, measure everything, then make a new one that's exact using this one as a template, and then make a second one that's exact using it as a template, and then make a new wing with those two and get everything perfect. This one, the prototype, once I've done testing it, I will put it aside, take the gear out of it, and just retire it and build a brand new one. But that being said, it's only because I don't want to ruin the prototype. Look at the details on the angles. There's so many things here that are going to be really hard to duplicate, you might think, but as long as you get the shapes of the wings right and the mounting right and the distances right, you will have a sweet flying little airplane all the time. You could even move this outside edge from the top wing in a little, or trim it a little straighter. Any of that would be okay and acceptable, but I have not only designed this to fly straight, but to turn well. Now here's the thing. The one wing is slightly angled outward. That is the bottom wing. You can see that. Okay. And they are actually the same. And then the other one is slightly angled the opposite way, swept back. And it gives a really nice flying effect because the whole thing is so locked in the air, you guys. It's just beautiful. And so this is going to be kind of me coming back into the RC world in a pretty serious way. Now, I apologize for the poor footage, but this will get better over time. I'm actually going to take it over here where there's a little more light. And this is one of the things I wanted to do on purpose. Okay, so you saw it in poorer light. This is the difference between you taking a quick look at it and taking a really close look at every detail of it and making sure that it's right. Making sure you don't have too much glue in an area. Making sure that all the little details line up. This is the RXD BPX1. It stands for Robinson Extreme Design Biplane Extreme 1. This is meant to be 3D capable. It'll do any maneuver you want. It has double ailerons, a nice big tail, but not too crazy, because while I want to be able to do some maneuvers, this has actually been designed for me to fly, and I actually like my tail surface just a little smaller and my rudder surface a little bigger. No, I like the elevator a little bigger and the rudder a little smaller, so that's how I've designed it. I like nice big ailerons, but with a bit of stiffness to them, so they're not too sensitive. They won't be stiff, but they'll be perfect, which means everything on this will be dialed in and is been dialed in to the point where it flies flawlessly, which is weird because there's still a couple of visible flaws where it's not perfect, and yet it flies in such a way as to belie all that. It weights slightly to the left but doesn't show it, which means it can tolerate these little imbalances as you build it, and it is such a stable design that inherently it is incredibly stable. In fact, it's so locked in and has so much lift that those things have not made any difference to any of the flight tests I've seen. So it is also begging for more weight, like I said. So here's the trick. Now that you've bragged about your design, you think it's great, you love it, you got it all tested, it works awesome. Stop. I could put RC gear on this right now if I had the money to buy the gear. In fact, I've already started to order the first of it. I have my full motor power pack, my batteries, the connectors are soldered up. I now need an ESC and a couple other things. I might need one more additional connector, but I can just pull it off one of the things I have to make one setup that works perfectly. But before I do that, I want to try with all the gear in it and try a weaker battery. Then I'll try up a stronger battery if I need to. Just to make sure, just like I have with everything else, it has to be tested. It has to be dialed in before I say, okay, it's done. So this series is to show you how to design your own. First design the top wing, then test it. Then design the bottom wing, then test it. But test them independently as totally separate wings. If you can, get inspired by the surface design and try and design a separate tail that matches. That way, when you're done, you'll have two tails and two full wing surfaces. Now when you put the two together, you have two tails to choose from. And that is usually a good thing, believe it or not. And it's one of those things. You get the angles right, guys. You notice the slightly outturned wingtips, meaning it's raked out forward instead of swept back, like the top wing. And yet, at the back, they're pretty much both the same. Ailerons are matched, all that stuff. This is beautiful. I mean, it's pretty damn symmetrical. And I challenge you to find where it's not. That's the thing. I mean, it's close. And that's what I was saying in the videos. You can have it a little imperfect, but it has to be close. And you might not think an imperfection as big as that could be, where one is noticeably higher than the other. But it is, and it flies perfect, and you'd never notice it. And that's one of the beautiful things about this particular design. In addition, it has leading edge slats, just like stall planes. And these slats have VGs on them, just like stall planes, which means you can adjust those back and forth, and that was part of my design. In addition, you have the ability to dial in flaperons, which means you can make this so awesome as a 4-channel setup, guys, that it is going to be such a sweet little flyer. I honestly believe this is the best biplane that you could buy on the market, and I honestly believe that it is going to be absolutely the very, very best indoor flyer you could ever hope for, because I'm engineering it to fly slow. Now, that being said, some things are still being engineered, like my power system. I've told you how I'm going to do it. Next step is doing it. But for that to happen, I need the final weight of this to be set, which means I need the servos so I can install them. I'll install them with as little glue as possible so I can pull it all apart and break a brand new one with that gear. Then I'll put this one aside. One set of servos goes inside. I've already described all that. All I really want to cover in this video is once you're happy and you've got a good design, basically what I do is I decide that the lower one is actually an accident, not the higher one, and I want it to this spec. So now I pull the wings, I blueprint all this, I make it so it doesn't ever get destroyed. So I can always go back and use this one as a template. Better than that, I take it all apart, which is what I'll end up doing. Taking all the pieces, putting them in a bag, separate, putting them in a file folder, which I have here. Et voila. And it has a couple in it already that I've pulled apart, because most of the ones that I built before have been dismantled, and the ones I liked I kept, and the other ones I still want to do other things with eventually, and they're going to be used for outdoors because they're just too fast. But I want to fly them and see how they fly and all that stuff, so that's going to be fun. But that'll be a project for the spring. In the meantime, my goal is to get this finished and turned into an RC. Now, I don't want to mention the name of the hobby shop, but I had a very awesome group of people offer to sponsor me, guys. And if they are serious, I will find out soon, because I told them I would design my own aircraft and it would be a cool indoor flyer. And they were already offering me to sponsor, but to fly other aircraft. And I really wanted to do this first and make my return to the RC world doing what I've always done. Being an inventor, creating, designing for you guys, and helping you to get hold of the cool things that I design. And believe it or not, I really do design some cool things. And everywhere you look at this, you'll see more of those cool features, both in the toughness of the landing gear, the springiness of it, everything. Every little detail of this has been fine-tuned and dialed in so that it works beautifully, even with the little imperfections, like this little tiny bit right here. You don't see it here. It's smooth. So it has to be adjusted. But that is such a minor thing, guys. Same with a little bit of glue on one side that isn't on the other. This is such a rock solid machine. None of that will matter. But it is weighted a little bit to the left on purpose because the prop will turn right and that will help to counteract it. There is a lot of really quality engineering and design that is in this, and it is actually the very best, most advanced biplane design ever in human history. It is the most advanced stall biplane ever made. Literally, that's a fact because it flies and it works and it actually does all that. It is incredible, and there's never been one that had the leading edge slats like a stall plane. This is a combination of a stall plane, a biplane, and a 3D biplane all at once, making it the ultimate beginner 3D biplane for indoors. So in this series, I've showed you the upper wing, which is a great wing if you want to make a 2-channel setup or a 3-channel. On a 2-channel, you're using the throttle to climb and dive, which means you want to make the angle on the wing pretty aggressive, make its lift profile pretty aggressive, and it'll do that. Then you have your control over your ailerons, hopefully. I recommend if you're going to do a 2-channel, don't do a 3-channel and do the elevator and do your ailerons. And you will get so much control out of that, guys. And on top of that, you have your throttle. And the way I've engineered these, you will have enough lift that when you come hard onto the throttle, it'll climb. So you can use that to help you control your altitude. But the idea is you launch it at the height you want to fly it at, and then you fly around. So if you put on the throttle, it'll climb a little bit. That's perfect. You won't really need your elevator for this build, believe it or not. And that's a fact. You could just make it so the control surface is there and stiff enough that you can bend it up a little tiny bit if you find you need to. But that's all you want to be able to do. That's all you're going to have to do. But I really recommend that you have control over both of these, period, which means 3-channel. That'll give you real control over your elevator, real control here. Now, if when you test it, you have built it right and you find that it's climbing with the amount of weight you're going to put on it and it climbs, you have more lift than you need, and you need to flatten the wing a little bit or reduce the size of your VGs or both until you have the lift right. Now, once you have that, also you can increase that and add extra VGs to make it so that it works well. I recommend a second one right here, guys. If you're going to do that on this wing, right over top of where the ailerons are, just like you see on this one. And since there are so many details to this, I mean, look at how many details there are on this. How many angles, how many little things. What do you think the odds are you get this right if you just suddenly try and rebuild one? If I build another one, it won't be quite identical. Unless I blueprint it and take proper measurements and dial it all out and lay it all out. Even scan it into a 3D programmer. I have one on my phone, and I'm actually going to scan this biplane in and ask it to make it for me. The problem is it will, and it'll scan in any imperfections. Sorry, guys. So, the purpose of this stage of the invention is blueprinting. Now I have a satisfying design. I know it's going to work. It does everything I want. Now comes the final test before the blueprinting, where I put everything on it, make sure that it works, make sure I have my lift angles correct. Once I do, I put a blocker right here, another support that'll lock the wing in place in the middle of the wing so it's rock solid. Right now, this is changeable. Changes every time it crashes. It changes for a lot of things because they've been bent so they'll move. The idea is you have these to help you dial in your lift factor, so that as you put on more weight, you can adjust these. And it works, guys. Between that and the fact that you can adjust the arc of the wings, you can really dial it in. So what I did was dial in this one until it was perfect and lock it in. Dial in this part until it was perfect, lock it in. Dial in this until it's perfect and lock it in. With bracing, and that'll give it one more brace here, but it'll be a vertical one, straight up and down, which will actually help it fly on the side, because you have one winglet basically going each direction if you really look. One in the wing root and one at the wing tip. With one in the middle, This will just help it to lock in and fly incredibly, guys. So that is the last of the design engineering changes I am actually going to make. There's actually one more to the landing gear. I've designed a better system than that, but from the top down to where that little stack starts at the bottom of the landing gear at the top of the ski, that's going to be removed and replaced with little homemade leaf springs that are made out of this same material instead of that little stack. But those are literally the only changes I'm going to make because this flies so perfect, guys. I don't want to mess with it. That also means when I do the first couple flights, they'll be very brief, and all you'll see me do is verify that it flies perfect, that it really does work as well as I think, and it flies amazing. Once I have that, I stop it, I turn it off, I take out all the electronics, strange as that sounds, and now I scan the whole thing in to a 3D printing program setup. And then I can 3D print all my components because the components are all easily 3D printed, guys. Every bit of this is easy to 3D print. And this is a great design. Take a look at the bracing up at the top and then in the middle and then at the bottom. It's a 3-layered bracing system. And it's really nice. Oh, I guess I should show you the tail one. It's actually on a little leaf spring already. That's where I got the idea. I did it there and it worked awesome. So I'm going to follow that through. But this one's a long video now. I apologize, but there's always so much more to talk about with engineering, guys. Because now that I have a sick design, what do you do with it? Now, if I had the money, I'd be patenting this shit, but I don't. So what I'm going to do instead is put it up for you guys. Hopefully you guys will enjoy this build. It's wonderful. If anybody ever makes a real biplane like it, please come take me for a ride. I can't wait. Keith out.